Okay, so let's take a look at an example of a problem from the problem set. Oops. Okay, so what about one like this? This is from the assignment from the section 3-4 assignment. Right, there those two assignments that kind of go together, the 3-3 and the 3-4 assignment. Now let me just very briefly remind you what the difference is. They are almost identical. The difference is that the reasons that you're using, the theorems and postulates that you're using on the first assignment, the 3-3 one, those are things like, for example, if two parallel lines are cut by a transversal, then there's a bunch of stuff that's true. Alternate interior angles are congruent, for example. Corresponding angles are congruent, etc., etc. We have a bunch of relationships. On the 3-4 assignment, we're doing converses, right? We're saying if corresponding angles are congruent, then the lines are parallel. Okay? So we're flipping it around, right? And so when we look at a problem like this, like what about this guy right here? It says, given that angle 2 is congruent to angle 8. So let me, there we go. So if I do that, so this guy is congruent to, oh, those are big lines. Oh well. Okay, so those two angles are congruent. First of all, are lines A and B parallel? They are, aren't they? Right? So, oops. So we'll go ahead and choose yes. Okay. Now here's the part people are having trouble with. Enter the postulate and or theorem that explains why these lines are parallel. Now this is the stuff, these are the reasons. Where do you go to find these? Here's where you go to find these guys. We'll come back to this in just a second.
How many is there for each problem?
What do you mean?
Like, is there more than one?
More than one reason? There are a couple of problems where there is more than one reason.
So every time that I put one in there, it would say that I got the two reasons.
Okay, yeah, I'll tell you, you'll see why here in a second, why that happened. Okay, so where are these reasons, first of all? So if we go back to the geometry homepage, the reasons are right there. Okay, if I pull up this document here, how come it didn't open that up? That's weird. Does it do that for you, or does it open it up? It should just download when you click on that. Does it not do that for you? If you open that up, does it just give you a new document? If I do that, open in a new window. Oh, I guess I can do that. Cool. That's weird. Does it do that for you guys?
Yeah.
Oh, she printed them out? Okay, well, here they are. I don't know why they're not. I'm not sure why those are. That's not just downloading to your computer. Maybe I've got a setting wrong. But it should. You should get this. The stuff that you got printed out, that's where it is on Moodle. If you need to print it again, or if you just want to use Moodle to, to pull that up in a separate window, take your pick. But it should look like this. Let me go ahead and just pull that thing out. Okay, so here's what it looks like. Okay, these are your reasons. Now, what do you type in for these? You don't have to type the whole thing, except in a few cases. There actually are a couple of them later on where you have to type the whole darn thing because there really isn't a name for it. But what I want you to do instead for now is just type in the underlined part. That's the name of the reason. For example, we know that if two parallel lines are cut by a transversal, then pairs of consecutive interior angles are supplementary. That's a lot to write. So instead, you can just write consecutive interior angles here.
You have to do capital S letters.
No, you don't. You don't. But notice that if you go down to the next page, the ones that we get from 3-4 are different. Look at the alternate interior, no, the consecutive interior angles converse. Okay. If two lines are cut by a transversal so that pairs of consecutive interior angles are supplementary, then the lines are parallel. That's not the consecutive interior angles theorem. It's the consecutive interior angles converse. That's an important word. You have to include that in the reason because it's the backwards version of that relationship. Okay? So those are the reasons. Here's the comprehensive list of all the reasons. So if I've got that list, then I'm set. Oops, darn it. Okay, so back to this guy. So then what's our reason? Okay, what's the reason then? We said 2 and 8 are congruent. What's the reason that we know then that those two lines have to be parallel? What kind of angles are those? Alternate exterior. Now technically, you'll notice if you look in the book, technically there is no alternate exterior angle theorem or alternate exterior angle converse, but there should be because it always works. And so we're just going to, we proved it for ourselves, so we'll use that. Rather than you having to enter a bunch of steps, you can just enter alternate exterior angles theorem or alternate exterior angles converse. Which one applies here? No. Because we're trying to show that the lines are parallel, right? So we want the one that says if alternate exterior angles are congruent, which we're told, then the lines must be parallel. So it's the converse. And that's why people were, if you were getting frustrated because you're missing that one, that's why. So if I put in, let's enter that. Now watch what happens. If I just put in alternate exterior angles, look what it does. It gives me partially correct. Okay. Hey, can you guys back there? Seriously, that's enough. All right. Put the phones and stuff away, please. If I look over these things, then this is I got 7.5 out of 10. So I got full credit on this one, but I only got half credit on this guy because that's not correct, right? It should be alternate exterior angles converse. Yeah. On this assignment, they would all be converses, right? Because you're proving lines are parallel. Okay. Okay, make sense? Does everybody see where we're getting these then? Okay, they're just off of that sheet. How many people, how many people are done with 3-3? How many people are done with 3-4? Almost, or did you were able to get it, or? This is why, yeah. So other than this one issue, some people are already done with 3-4 then too. Okay, okay. Yeah, you can. Okay, so. Okay, so I want to go through something real quick, and this is very, very minor. The next section doesn't add hardly anything. It's super minor, very, very limited stuff in there. All we're going to do in the next section in 3.5 is just add a couple of extra reasons that are much easier to work with. Here's one of them that we're gonna get. We're gonna learn in section 3.5 that if I've got these three lines, M and N and K, we're gonna learn that if M is parallel to N, and N is parallel to K, then M must also be parallel to K. And that's just one of about, 4 reasons we're gonna get in 3.5 that we can add. And I'll show you what those are. They're on that list of reasons that I just showed you. And you'll get to practice using those a little bit. But I do want to take this one opportunity with this one example here to prove this. Let's go through this and let's go through, it's a very short proof, but let's go through it together just so we get a little bit more experience with how we prove things like this. So I'll make my 2-column template here. So we've got steps and reasons, or what do they call them in the book? They call them, I think they call them steps. What do they call them? I want to use the same vocabulary that you do. Just look here. Statements. That's it. Statements and reasons. Okay. Okay, so we're given this stuff. We're trying to prove that. Where do we start? Where do we always start in a proof? It's always the same. The given statement, right? So the first thing we're going to do is we're going to say, okay, step 1 is, for example, line M is parallel to line N, and the reason for that is it's given to us. Okay. What else? Yes. Okay. Yeah, so we can also then for step 2, and the order, the order might get mixed up a little bit from one person to the next, but we also at some point have to bring that up. So N is parallel to K for same reason, given. Okay. Now what? Now let's start marking this thing up as we go along here. What does that tell us? If I know that M is parallel to N, does that tell us anything interesting about that picture? Yeah, okay, we could write that in. So we know this. Those two are parallel, and those two are parallel, right? What about the angles? Let's just focus on the first two. The fact that M is parallel to N, does that tell us any angle relationship? What? Oh, 1 and 2 are congruent. Yeah, good. So 1 is congruent to 2. Okay, so let's add that statement. Angle 1 is congruent to angle 2. And what's my reason for that one? What's my reason for that one? Corresponding angles. And I don't care if you write corresponding angles postulate or it's actually corresponding angles theorem. I don't care if you write that part. All I care about is corresponding angles. That's all you have to write on your reasons, corresponding angles. And we know it's either a theorem or a postulate. We don't care which one. So the reason here corresponding angles. Okay. What else do we know? 2 is congruent to 3 for the same reason, isn't it? So we know 2 and 3 are congruent. For same reason. Okay, now this is one that's a little bit different. If we know that angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, if I pull up this list of reasons here, which is where... Oh, did I delete that already? I think I did. Darn it. Okay, why is it that if angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, that angle 1 is congruent to angle 3? You see a reason up there that seems to fit that? Yeah. Well, not symmetric. Transitive, isn't it? Transitive. here it says A and B instead of 1, but we could change those, right? Instead of A, we have a 1, instead of B, we have a 2, instead of C, we have a 3. And that's always true. If A is congruent to B, doesn't matter what A is. Could be an angle, could be a line, could be a square, could be a triangle, anything. If geometric object A is congruent to object B, and object B is congruent to object C, then we know automatically that A and C have to be congruent by that reason, transitive property of congruence. Okay. So, very good. So we got it. That's our last reason that we need it. Okay, so now we know angle 1 is congruent to angle 3 by transitive property of congruence. Okay. Make sense? And we proved it, because the last statement is always going to be what we're trying to prove. And once we get there, oops, no, we're not there, sorry. Okay, one more step. One more step. We weren't trying to prove the angles congruent. We were trying to prove the lines parallel. Forgot. Right? So then what's the last step? Now, if we know that these angles are all congruent, and in particular we're looking at those two, how could I show that M is parallel to K? What do you think, Julie? Okay, yeah, and what's our reason that goes with that? What kinds of angles are those, 1 and 3? Corresponding, right? But now, is this going to be corresponding angles or corresponding angles converse? Converse has to be, doesn't it? Because we're proving the lines parallel. We're saying if the angles are congruent, then the lines are parallel, right? And so our final step then is M is parallel to K by corresponding angles converse, right? Okay. Make sense?
Yep.
Okay. All right. So then, what do we get in this? In this next section here, I'm going to skip through the proof. You did a great job on proof, so skip that. Here's what we get. A couple new reasons. The transitive property for parallel lines. That's what we just proved. That's its name. Transitive property for parallel lines just says that if line P is parallel to line Q, and line Q is parallel to line R, then I can transfer that, just like we can transfer congruence, we can transfer parallelism also. So P and R must be parallel. It's a transitive property. Okay, we got another one. Transitive property for perpendicular lines. Now this one's a little bit, the title's a little misleading. It says if M is perpendicular to P and N is perpendicular to P, then M must be parallel to N. Okay? Two lines are perpendicular to the same line. If it's all in a plane, then those two lines must be parallel to each other. So the title we give that, transitive property, perpendicular lines. And then I think that's it. I think just those two. Yeah, it is. Just those two. That assignment's not quite ready yet. I probably won't get it ready until after school today. There's just a couple more problems I want to tweak, and then just a little bit better. But that one's, you're ready to do that one. It's a very short assignment. Why don't we head down to the lab